Hello students, today we will take up with the topic sets, relations and functions. You have studied about sets, relations and functions already. Just recall all the formulas related to that. So, first consider sets. What is a set? You know that set is a well-defined collection of objects, and we know that to denote a set we'll use capital letters, and elements of the set are written within the flower brackets separated by commas, right? So, consider a set like this. Set is denoted using capital letter. Elements of the set are written within the braces separated by commas, right? Then cardinality. Cardinality of the set means number of elements in the set, that is denoted by n of a. Now it is 3 elements in the set A, so n of a is 3. Next come to the point subset. So subset is the smallest set considered from the given set. Suppose if we consider set A, it has 3 elements. Number of subsets can be formed using A, that is formula 2 to the power n, that is 2 to the power 3, that is 8. Next consider power set. Consider power set. So power set, it is the set of all the subsets of the given set. Power set is the set of all the subsets of the given set. Next consider null set, set without any entry, denoted like this. Consider singleton set, set with one entry. Consider universal set, notation used for that is U. Next consider Venn diagram. Next come to the point relation. So relation denoted by R always, it is the subset of A cross B. A cross B, it is the Cartesian product of A and B. Okay. So relation is a subset of A cross B. Suppose n of A is n, n of B is m. Then number of relations can be formed is number of subsets actually. So that is actually 2 to the power mn. So all the formulas are given in the synopsis. We have a formula when two sets A and B are given, n of A union B, that is n of A plus n of B minus n of A intersection B. Similarly, when 3 sets are given, we have the formula n of A union B union C. See here, n of A union B union C equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Okay, this is the formula when 3 sets are given. You can use the formula or you can use the Venn diagram also to simplify the statement problems. Next, suppose if we have the Venn diagram like this. Suppose this is a set A, this is a set B, this region indicates A intersection B. This region indicates A only. This region indicates B only. All together gives you n of A union B. All together gives you n of A union B. So this is only A only. This is B only. A only means it is actually A minus B. This is B minus A. Then if you add all the 3 together, that gives you n of A union B. N of A union B. Next consider functions. Suppose consider 2 real functions f and g. F and g, 2 real functions from R to R like this. Then you can add those 2 functions. You can get the subtraction also. You can get the product also and division also when g not equal to 0. All these things are familiar now. So we'll consider the questions one by one. While solving the question, I'll give you the concepts related to that. Okay. So no need to write down the question. Just write the solution. So write the question number 1 and write the solution. So no need to write the question. Afterwards link will be given. So first question. The number of proper subsets of A containing 1, 2, 3, 4, 5. So how many entries are there in A now? 5 entries are there. So n of A is 5. Question is, see, number of proper subsets. So listen to me now. Under subsets, two types. One is proper subset, other one is improper subset. Proper subset means it is properly contained in the set. So improper subset is always 1, that is given set itself. So here number of subsets, that is 2 to the power n, that is 2 to the power 5, that is 32. In that 1 is improper. So how many proper subsets remains then? 32 minus 1, that is 31. 31. So which option matches with now? Second option. Remember, number of improper subsets is always 1, that is given set itself. So number of subsets, that is 2 power n, that is 32 now, 2 power 5, that is 32. So from 32 subtract 1, that is improper. So we'll get number of proper subsets, that is 31. So option 2 matches with, right? Consider second question. In a hostel accommodating 200 students, 50 like coffee, 75 like upma, 35 like both. Number of students like neither of these. So consider, see, if you observe the statement, two sets are there. One who like upma, one who like coffee, right? So we can form two circles over here. One for coffee, one for upma. Total how many are there? That gives you universal set. How many are there? 200. So this is for universal set, n of u, right? Consider the one who like both, that number of students who like both coffee and upma, that is 35. So you have to fill up here first. So that is 35. Then number of students who like coffee, that is 50. 35 is there already, so this should be 15. Then number of students who like upma, that is 75, but 35 is written already, so this will be 40. Now listen to me. The question is number of students neither like coffee nor upma. So they does not belong to these region. That means from the universal set, means from 200, you have to subtract this 35 plus 15 plus 40. That gives you 90, right? So 200 minus 90, that is 110. So this is option 2. Number of students who do not like coffee, do not like upma. Neither coffee nor upma. Not belonging to this shaded region. They do not belong to this. This gives you union actually. 15 plus 35 plus 40. If we add all these three, we'll get the union. We'll get the union. This region I am telling. This one. If we add all the three, 15 plus 35 plus 40 gives you union. So from the universal set, if you subtract union, we'll get the remaining one, that is complementary part, not belonging to this. That is 110 now. So answer 2 matches with second option. Consider third question. If A contains m elements, B contains n elements, then total number of distinct relation from the set A to the set B. See, it is number of relations we can form. It is given that n of A, that is n, n of B, that is n of A is m, n of B is n. So relation, it is the subset of A cross B. So A cross B has m into n elements, means mn elements. So number of subsets is 2 to the power mn elements. 2 to the power mn elements. So number of relations we can form from the set A to the set B is 2 to the power mn. 2 to the power mn. So if we compare with the options, answer D matches with. Answer D matches with. Consider fourth question. If R is the relation defined as, see the relation is given already. It is the set containing ordered pair 3, 2, 4, 3, 5, 4 and 6, 3. Question is, you have to write R inverse. Remember, while writing the inverse, you have to read reverse. See, earlier it is 3 to 2. Now you have to read back. That is 2 to 3. So check with the option which contains 2 to 3. So in A it is there, in D it is there. So other two you can omit out here itself. 4, 3. You have to read from reverse side now. 3 to 4. So check with first 3, 4. It is there. Here also it is there. Consider 4 to 5. 4 to 5. If you consider option D, 4 to 5 is not there. 4, 5 is not there. So you can leave this. But in the option A, you have that. 4 to 5. Consider last one. 3 to 6. It is there. See here. 2 to 3. 3 to 4. 3 to 4. 4 to 5. And 3 to 6. So this is the answer. Answer A is the correct answer. Answer A is the correct answer. Consider fifth question. If f is a real valued function defined by f of x is equal to root of x square minus 16, then domain of the function. So domain means the value which you are going to substitute in place of x so that the function is defined. That means f of x is root of x square minus 16. So this is the function. You have to replace x by the value so that this function is defined. As it is under root, this should be greater than or equal to 0. That means x square minus 16 should be greater than or equal to 0. If it is less than 0, that is not the real valued function. That comes under complex number part. So we don't want that, right? So f is a real valued function. So x square minus 16 should be greater than or equal to 0. If you simplify this, x square greater than or equal to 16, x greater than or equal to plus or minus 4. So minus 4 to 4 we can form, right? Minus 4 to 4. So you can write this as the closed interval. Closed interval minus 4 to 4. Like this also you can write. Now check with the option. A cannot be, C cannot be, D it is open interval. Observe this is open interval. B holds good. So answer is option B. You can write like this also, closed interval minus 4 to 4, or like this, minus 4 less than or equal to x less than or equal to 4. Suppose in this case, suppose it is 1 by root of x square minus 16. Suppose it is 1 by root of x square minus 16. In such cases, we cannot consider equality of 0. So it should be always greater than 0 in that case. Because it is fraction, denominator cannot be 0. Now it is not fraction, so we consider that greater than or equal to 0. Okay. Consider next question. A set has 6 elements. Maximum number of relation on A. Now listen to me. There are two concepts. One is relation from the set A to the set B. In this case, it is the subset of A cross B. Now it is relation on A. That means it is a relation from the set A to the set A itself. It is a relation from the set A to the set A itself. So it is the subset of A cross A. It is the subset of A cross A. So now A has how many elements? A has 6 elements. So A cross A has how many elements? 36 elements. So how many subsets we can form? 2 to the power 36. How many subsets we can form? 2 to the power 36. So relation is the subset. So how many relations we can form? 2 to the power 36. So option C is correct answer. Option C is the correct answer. Consider question number 7. If A has n elements, then number of subsets, this is formula itself, number of subsets you can form from A, that is 2 to the power n. Let A and B be two finite sets, n of A is 3, n of B is 2, total number of relation from the set A to the set B. First get what is A cross B. A cross B, 3 2s are 6. So number of relations 2 to the power 6. So 2 power 6 is 64. 2 power 6 is 64. So option C holds good. Option C holds good. Next question. 9th one. The number of elements in the range of a constant function. Range of constant function. Just recall what is constant function. A real valued function f from R to R is said to be a constant function if it is defined like this. Y is equal to f of x equal to c, where c is a constant. Where c is a constant, means a fixed value, right? Now, domain, you know that. What is domain? Domain means it is the value of x you are substituting. After substituting x value, after simplification, what is the value you are getting? That is y value. That is considered to be range. That is considered to be range. In the constant function, after simplification, whatever may be the x value, we are getting c. After simplification, whatever may be the x value, we are getting y value c. It is fixed. So, in the range is a set actually. In the range, we are getting only one entry, that is c. So, this is the range of the constant function. This is the range of the constant function. So, in the constant function, the range contains only one element. See, the question is number of elements in the range. Number of elements in the range is 1. So, option B holds good. Option B holds good. Consider next question. Let R be the relation in the set n. N means set of natural numbers. You know that, right? Relation is defined like this. A comma B. Ordered pair A comma B such that A equal to B minus 2. One more condition is given. B should be greater than 6. B means second number, right? It should be greater than 6. Now, which are the options holds good? See here. Second number should be greater than 6. So, this cannot be. This is 8. This can be. But observe here, if you shift this, A plus 2 becomes B. So, if we add 2 to A, that should give you B. Now, if you take this option, you have 8. So, if you add 2 to A, means 2 to 3, 3 plus 2, 5. So, that is not equal to 8. So, this cannot be. Here, second number, that is 8, it is greater than 6. That holds good. First condition holds good. But if you add 2 to A, means 2 to 6, 6 plus 2 gives you 8. So, this holds good. Check with D also. This is 7, it is greater than 6. So, first condition holds good. What about the second part? Add 2 to 8. So, that is not equal to 7, right? 2 plus 8 not equal to 7. So, this does not hold good. So, what is the correct answer? C is the correct answer. C is the correct answer. Consider next question. R is a relation on n, means set of natural numbers given by R is equal to, it is a set containing x comma y such that 4x plus 3y equal to 20. Which of the following does not belong to R? Concentrate on this. Which of the following does not belong to R? So, how to check? You have to see, if you consider first option 5, 0. Replace x by 5 and y by 0 in this equation. 4x plus 3y equal to 20. Substitute here. So, equation must be satisfied. So 5, 0, 4 5s are 20, y is 0. So it holds good. So first option 5, 0 holds good. Consider second one, that is minus 4, 12. Minus 4, 12. Substitute here. Minus 16, 12 3s are 36. You are getting 20. So this also holds good, means that lies on that equation. Consider 2 and 4. 4 2s are 8. 3 4s are 12. Again you are getting 20. So this also holds good. So consider the last option, means 3 4. 4 3s are 12. 3 4s are 12. It is 24, not equal to 20. It is 24 now, not equal to 20. So last point does not hold good, means that last point does not belong to R depending upon this condition. So 3 4 does not satisfy this condition. So answer is D. Option D holds good. Consider next question. F is a relation from R to R. J is a relation from R to R, real to real, defined by f of x equal to 2x plus 3, g of x is equal to x square plus 7. Then the values of x such that g of f of x, it is composite function, g of f of x equal to 8. This should hold good, okay? Like that you have to calculate. So consider g of f of x. G of f of x, that is equal to 8 given. So g of, what is f of x? F of x is 2x plus 3. 2x plus 3, that is 8 now. Now g of 2x plus 3. So what is g function? X square plus 7. So simplify now. 2x plus 3 whole square plus 7. That should be equal to 8. If you simplify this, 2x plus 3 whole square is equal to 8 minus 7, that is 1. So what is 2x plus 3? That is plus or minus 1. So take two cases. 2x plus 3 equal to 1, 2x plus 3 equal to minus 1. If you simplify, 2x equal to 1 minus 3 minus 2, x is minus 1. Here 2x is equal to minus 1 minus 3 minus 4. So x is equal to minus 2. X is equal to minus 2. Remember, these are not the coordinates, they are the x values, minus 1 and minus 2. So which is the option? Minus 1 and minus 2. So option C holds good. Option C holds good. Next, consider 13th question. F of x is equal to 2x square plus x plus 1. G of x is equal to 3x plus 1. Question is, you have to calculate f composite g of 2. F composite g of 2. So this is composite function. You know how to simplify that, right? So how to simplify that? You have to write f composite g. Then write it as f of g of x, right? Write it as f of g of x. Wait 1 second, I'll rewrite. So question is f composite g of 2. F composite g of 2. How to simplify this? You have to replace this sign by a bracket f of g of 2. That is f of, what is g of 2? See here, g function is 3x plus 1. Now g of 2 is needed. 3 2s are 6 plus 1. So that is 7. Now f of 7 is needed. Substitute over here. 2x square. See, substitute here. 2x square plus x plus 1. So 2 times 7 square, 49 plus x is 7 now, plus 1. If you simplify all together, the value you are getting over here is how much? 106. So which is the option holds good here? For question number 13, answer is A. Consider question number 14. F of x is equal to x plus 1 by x minus 1. See, this is a given function. F of x is equal to x plus 1 by x minus 1. It's a real function. Then you have to calculate f of 2. This is to be calculated, right? So, I'll consider here only f of 2 is to be calculated. First consider f of 2. See, this is f of x. F of x is x plus 1 by x minus 1. So, what is f of 2? 2 plus 1 by 2 minus 1. 2 plus 1 is 3. So, f of 2 is 3. If you back substitute here, that is f of, see, this becomes 3 now, right? So, f of 3. This is to be calculated. Get back here. What is f of 3? What is f of 3 now? 3 plus 1, 4. 3 minus 1, 2. So, 4 by 2, 2. So, this value becomes now 2. So, what is the final value you are getting? F of 2. We calculated that already. That is 3. F of 2 is 3. I'll repeat. See, f of 2 is needed. First calculate f of 2 value. F of 2 is, see here, 2 plus 1 by 2 minus 1. That is 3. So, this becomes 3. Now, f of 3 is needed. Calculate f of 3. 3 plus 1 by 3 minus 1. That is 4 by 2. That is 2. So, f of 2 is 3. So, the correct option is C. Option C. That is 3 answer. Answer 3. Consider question number 15. The set of all natural numbers x such that 4x plus 9 less than 30 is equal to, see, the sets given. Consider one by one x values 0, 1, 2, 3, 4, 5 like that. But remember, set of all natural numbers. So, we cannot consider first option. Okay. So, check with B and C. So, 1 replace here, 4 plus 9 less than 30, 2, 8 plus 9 less than 30, 3, 12 plus 9 less than 30, 4, 16 plus 9 less than 30, 5. See here, 4 5s are 20 plus 9, 29 less than 30. This holds good. But consider this also, 1, 2, 3, 4, 5 is there already along with 6 now. So, 6 4s are 24 plus 9. It is greater than 30. So, this cannot be. So, correct answer is option B. For the question number 15, correct answer is option B. Consider question number 16. The set of all integer x such that mod of x minus 3 is less than 2. You have to find the value of x now. Okay. Now, listen to me. According to the definition of modulus function, a real valued function f from R to R defined like this, f of x equal to mod x. That means it is x when x is greater than or equal to 0. It is minus x when x is less than 0. So, if you remove the modulus sign, then you have to attach plus or minus to the other side of the equality. You have to attach plus or minus to the other side of the equality. Okay. Now, consider this expression what is given. Given like mod of x minus 3, it is less than 2. So, if you remove the modulus sign, then x minus 3 should be less than 2, should be greater than minus 2. See, I have attached plus or minus 2, right? So, simplify this. You know how to simplify this inequality. So, to remove this minus 3, add 3 throughout. So, minus 2 plus 3 less than x, minus 3 plus 3 becomes 0, less than 2 plus 3, adding 3 to each inequality, each side, right? Adding 3 throughout. So, 3 minus 2, 1, less than x, 3 plus 2, 5. So, the value of x lies between 1 to 5. So, 1 less than x less than 5. Equality is not there. So, start from 2 now. 2, 3 and 4. So, which is the option? The correct option is option C. 2, 3, 4. Remember, equality is not there. So, we cannot take 1, we cannot take 5. So, in between that, we have to consider the integers. So, 2, 3 and 4. 2, 3 and 4. Consider next question. A is the subset of B. You know that this is a subset notation. A is the subset of B. Means A is contained in B. Then B dash minus A dash. This you have to calculate. For this, I'll consider one example. Take universal set as 1, 2 and 3. 1, 2 and 3. Take set A as singleton set with 1, B as set containing 2 elements 1 and 2. Write A dash is 2, 3. Write B dash is 3. Now B dash minus A dash is to be formed. It should be there in B, not in A. We are getting null set. So the correct option is option D, that is null set. Correct option is option D, that is null set. You can use Venn diagram also to judge this relation, okay? You can get the conclusion there also. Consider question number 18. If a set A has n elements, then total number of elements in the power set of A. Set A has n elements. Now consider power set of A. So recall the definition. Power set of A. Power set means it is the set of all subsets of A. It is the set of all subsets of A. So how many subsets we can form? 2 to the power n. So how many elements will be there in the power set? 2 to the power n elements will be there in the power set. So what is the correct option here? Option C is the correct option. So power set means it is a set of all subsets. So number of subsets is 2 to the power n. So number of elements in the power set is 2 to the power n only. Consider question number 19. The number of non-empty subsets of the set 1, 2, 3, 4 elements are there. Number of non-empty subsets. Remember, number of subsets is 2 to the power n, that is 2 to the power 4, that is 16. In that, 1 is improper, remaining 15 are proper. But here, it is not proper and improper, it is non-empty. One empty set is there always, right? Empty set is the subset of all the sets. So, if you remove that empty set, what is remaining out of 16? So, 15 remains. So, answer is A. Correct option is option A, 15. Number of non-empty subsets, that is 15. So, for the question number 19, correct option is A. Now, consider question number 20. If A equal to, it has 5 elements, 1, 2, 3, 4, 5. Then number of improper subsets. Number of improper subsets. Remember, always number of improper subsets is only 1. So, option B is the correct answer. Number of improper subsets, that is 1. Consider question number 21. Consider question number 21. If a set A has n elements, then total number of proper subsets of A is 15. Then number of elements in the set A. Listen to me now. According to the statement, number of proper subsets, that is 15. Number of proper subsets, that is 15. And include one that is improper. So, total number of subsets we got 16. 2 to the power n, that is 16. So, 2 to the power n, that is 2 to the power 4. So, if you simplify, n is equal to 4. So, number of elements in the set A is 4. Number of elements in the set A is 4. So, option B is the correct option. Consider question number 22. If a set A contains 5 elements, the number of elements in the power set, number of elements in the power set, that is P of A, that is the question. So, how many elements are there in A? 5 elements. How many subsets we can form? 2 to the power 5, that is 32. So, how many elements in the power set now? That is 32, number of subsets only. So, option A is the correct answer. Number of elements in the power set is always number of subsets only, that is 32 now. See here, set A is given with phi and set phi as another element. Now you have to write the power set of A. You have to write the power set of A. Means you have to write all the subsets of A. So take first entry, take second entry with the flower bracket only, take given set, that is A, and null set. If you include all these four within the flower bracket using comma, then that gives you the power set, right? Set of all subsets of this A. How many subsets you can form? 2 to the power 2, that is 4. See, I have written 4 subsets now, right? That is, one is set with first entry, that is phi now. So, one set with second entry, that is this one, then given set and null set. So, if we include all these 4 in the flower bracket, that gives you the power set. So, option C holds good. Option C holds good. Consider question number 24. Let A equal to set containing 1, 2, B equal to set containing set 1, set 2, and C set 1 and set 1, 2. Then, which is true? So, consider first option, A equal to B. It is clear from the statement only A is not equal to B, correct? A is 1, 2, elements with 1, 2. B is different because first entry is set 1 it is. Set 1, set containing 1, okay. So, A and B are not equal. B is subset of C. Check whether all the entries of B are there in C. 1 is there, but 2 is not there. It is 1, 2, set containing 1, 2. So, B is not the subset of C. Check A belongs to C. Belongs to means it should be the element of C. 1, 2. Set containing 1, 2, it is there in C. So, option C holds good. So, correct answer is option C. For question number 24, correct answer is option C. Next, consider question number 25. If n of A is 3, n of B is 6 and A is the subset of B, then minimum number of elements in A union B. Minimum number of elements in A union B. Remember, A has 3 elements, B has 6 elements and A is the subset of B. If all the 3 elements are repeated in B, then if you take the union, remember always union is the larger set. If you take A union B, then union will be the larger set. Here larger set is 6, 3 entries are repeated already. If you take the union, minimum number containing A union B, that is 6. That is 6. Repetition is not to be entered. So, 6. Consider question number 26. N of A is 3, N of B is 6, A is the subset of B, then maximum number of elements in A intersection B. Maximum number of elements in A intersection B. See here, like previous question only, A is the subset of B. Imagine all the 3 elements are repeated, means common entries. Then if you take the intersection, then maximum number of elements is 3 only. If repetition is not there, suppose this condition A subset of B is not there, then it can be 5 also. Now repetition is there, so maximum number of elements in the intersection, it is 3. So option A is the correct answer. Consider question number 27. A suffix n is the set containing elements like this, AX such that X belongs to n. Then the set 3n intersection 7n is, now listen to me, AN is like this. Consider 3n. So it is a set containing elements, see n starts with 1, 2, 3 like that. So into 3. So it will be 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 6 18, 7s are 21, then 24, like this it goes, okay. Next you have to consider 7n. 7n, it is a set containing 7, 14, 21, 28, 35, like this it goes. So if you take the intersection of these two, see here, common entry starts with the 21. Common entry starts with 21. So if you take the intersection 3n intersection 7n, it is a set containing 21n form. 21n form. Don't add these two. It is intersection actually. So 21n form. So answer is option A. Option A. Consider question number 28. The smallest set A such that A union 1, 2 gives you 1, 2, 3, 5, 9. Remember, union of these two. A union with set containing 1, 2. Answer is given. 1, 2, 3, 4, 1, 2, 3, 5, 9. So 1, 2 it is there already. You have to write the minimum set such that this holds good, right? So what extra is needed? 3, 5, 9. You can consider 1, 2, 3, 5, 9 also. But minimum set is asked. Smallest set is asked. So it will be 3, 5, 9 only. You can check 1, 2 union with 3, 5, 9 gives you 1, 2, 3, 5, 9 only. So for the question number 28, correct answer is B. That is 3, 5, 9. Next one. Consider question number 29. 25 people for a program A, 50 people for program B and 10 people for both. So, number of employed only A. So, if you observe the statement, there are two concepts. Two programs are there, program A and B. So, first you have to fill up the common entry, that is for both, that is 10 now. Now n of A is given, for the program A it is given 25, you have written 10 already, so what is remaining over here? 15. N of B is given, that is 50, you have written 10 already, so it will be 40. Now the question is A only. A only means, as I said earlier, that is this region, A only. So what will be the answer then? N of A only is 15. N of A only, it is 15. Suppose a question with B, B only, then answer will be 40. Suppose the question is union, then 15 plus 10 plus 40. So 40 plus 10, 50 plus 15, 65 will be the union actually. Okay. So for question number 29, correct answer is answer A, that is 15. Consider question number 30. Question number 30. In a class of 175 students, the following data shows number of students opting one or more subjects. Mathematics 100, Physics 70, Chemistry 40. Mathematics, Physics 30, Mathematics and Chemistry 28, Physics and Chemistry 23. Mathematics, Physics and Chemistry, that is 18. The number of students who have opted mathematics only, mathematics alone, that is to be calculated. So if you observe the statement, three sets are there, maths, physics and chemistry. So we have to draw three circles like this. We have to draw three circles like this. A, that is mathematics, then I'll consider physics, then I'll consider chemistry. So first fill up all the three. So that is 18 now. That is 18. Next consider 2 to each. Maths, physics. See here. Maths, physics, that is 30. See, 18 is there already. Out of 30, 18 is considered. So remaining one is 12. Consider physics, chemistry. Physics and chemistry, that is 23. So 18 is there already. 18 is there already. So the remaining number 5. Consider mathematics and chemistry. Mathematics and chemistry 28. So 18 is there already. So this will be 10. Now come back to the statement. The students opted maths, that is 100. Out of 100, you have considered these numbers 12 plus 18 plus 10. 12 plus 18 plus 10. So 40 you have considered already. So the remaining one will be 60. Remaining one will be 60. Similarly, you can fill up this. You can fill up this also. But here that is not needed. See, the question is number of students who have opted mathematics only. Who have opted mathematics only. Only mathematics means this region. So that gives you 60. So correct answer is 60. That is option C. Correct option is option C. So remember, while drawing diagram, first fill up A intersection B intersection C. That is this one. Then consider 2 together. Subtract this part. Write remaining here. Then consider full set. Subtract this portion and write here. That is M only. Here it is physics only. Here it is chemistry only. So here correct answer is option C. For question number 31, n of u is given, that is 20. N of A is given 12. N of B is given 9. N of A intersection B, that is 4. U is the universal set. A and B are the subsets of U. Then N of A union B complement. That is the question. So, to get N of A union B complement, first get what is N of A union B. Get N of A union B. According to the formula, this is N of A plus N of B minus N of A intersection B. N of A intersection B. N of A is given 12. N of B is given 9. Intersection is 4. So, if we simplify this, that gives you 17, right? Now, consider complement of this. Total N of universal set is 20. So, from that you have to subtract 17. That gives you N of A union B complement. That is 20 minus 17. That is 3. So, correct answer is option D. Correct answer is option D. Next, consider question number 32. Question number 32. In a class of 60 students, 25 students play cricket, 20 students play tennis, and 10 students play both the games. Then number of students who play neither, not cricket, not tennis, that is to be formed. So, for this, again if you observe the statement, two sets are there, cricket and tennis. The one who play both, that is 10. N of C, number of students who play cricket, that is 25. So, you have written 10 already. So, this becomes 15. Number of students who play tennis, 20. You wrote 10 already. So, this is 10. Now, if you consider all together 15 plus 10 plus 10, that gives you union. So, N of C union T, that is 15 plus 10 plus 10, that is 35. So, neither means it is complement. So, N of C union T complement. This is the question. So, from the universal set, so how many are there? 60. So, out of 60, you have to subtract 35. So, answer is 25. Answer is 25. So, the correct option is option D. Option D. For the question number 32, correct answer is option D. See, I have solved 32 questions in the class now, discussion paper. One more paper is there for you. You have to practice that as the homework assignment. Okay. So, follow the same rules and solve that. Now, if you recheck with the answers what you have marked, we'll rewrite the answers again. Okay. So, I'll quote all the answers now. You have to recheck with your Recheck with your answers what you have marked, okay? Okay, first one. For the first question, second option holds good. For the second question, second option holds good. For the third question, option D. Option D. For the fourth question, option A. For the fourth question, option A. For the fifth question, option B. For the fifth question, option B. For the sixth question, option C. Sixth one, option C. For the seventh question, option C. For the eighth question, option C. For the ninth question, option B. Option B. For the 10th question, option C. Option C. For the 11th one, option D. 12th one, option C. 13th one, option A. 13th one, option A. 14th one, option C. 14th one, option C. 15th one, option B. 16th one, option C. 16th one, option C. 17th one, option D. Option D. 18, C. 18, C. 19, A. 19, A. 20, B. 20, B. 21, B. 21, B. 22, A. 22, A. 23, C. 23, C. 24, C. 24, C. 25, 25, C. 26, A. 27, A. 28, B. 29, A. 30, C. 30, C. 31, D. 31, D. 32, D. 32, D. So, before concluding this session, I'll tell you one thing. Just go through all the definitions first. List out all the formulas related with sets, relations and functions. Then solve the question. So, if you have any doubt, just go through the formulas again and check back. Then solve all the home assignment problems also. Thank you.